Hello everyone, I'm Xiao Gang. Let's continue. In the last lesson, we basically set up the framework. Now we need to fill in all our logic. Remember the diagram we drew earlier? Yes, the 1, 2, 3, 4 we drew earlier. Sorry, I don't have the drawing board here, but it doesn't matter. So here we have our A, B, C, D, right? After consulting A, B, C, D, we return to this place. This is the first mode of our head synchronization framework. Next, we will make it asynchronous. Make it asynchronous. Just erase it directly. Just close it and open a new one. Okay? Now, after initialization is complete, we need to be able to successfully receive the callback. Now let's add some code, because we only updated the progress. Actually, at this point, the continual flow here should be placed below. The position here requires some adjustment. I think putting it below should be fine. Then here, we have an init progress. We'll just broadcast it. Then what do we pass here? We pass a true line. Then if we give a program here, we give a message, init-006. Okay. Then it's just a semicolon. Then after this execution succeeds, it will hide our main interface. We'll still take it step by step. Actually, a lot of the content in this chapter is gradually leaning towards the idea of commercial development, so it's not good. 可贴完套子贴不骗的夯他好 because you might not be able to absorb it that way. Like this. Okay. Here you can see our convex hull generation succeeded. It says success here, right? But it doesn't seem to have been hidden. Let's check why. Here in the init, it actually already succeeded. Right here, because we selected the wrong one. So this way, it works. Okay, see no problem at all, right? And if we fail, actually, we'll just keep this box displayed. Let it click again. Should be fine. Normally, we should display the reason for the failure. These are all small details. And here, let me emphasize this for everyone. Set game. Set game input. This place. Let's see if we might need to get the player controller here. Let's check. Get player controller. Let's ignore this for now. Let's just get it this way for now. Then set game. This thing. Everyone should have used this before, so I won't go into detail. It just makes the UI or the game receive your keyboard and mouse input. Because sometimes when we operate the UI, we don't want that. When we operate the UI, our character is still moving. We want only the UI to accept up arrow and down arrow, left arrow and right arrow, mouse clicks and such. That is, sometimes we use this thing. This should have been covered by your blueprint instructor in a lecture. We won't go into detail. You just need to know roughly that here. There is such a method in pair control. And what you should note is, you can see that here we are actually still executing within one frame. Next, we will make it. I also need to convert it into this framework. Hey, clicked the wrong spot here. We convert it into our second framework. The second framework is actually the same as before. 1, 2, 3, ... Then the second framework is tasky. And after task A's direct line is done, come back here. It's ABC, right? AB, C, AB, still ABC. ABC. So after this part is executed, now I don't know which frame it is. It might be the N8 frame. This is N plus M pins. Now it executes B and finishes execution. Then it comes back here at this point, ABC. Let's now take a look at how this framework achieves a simple and clean utilization through our control flow. Okay, we'll just close this. Then we need to use the knowledge we learned in the previous chapter. Here, we'll actually place it at this position. That is, when triggering local assets. Then we shouldn't write it here. This thing shouldn't be placed here either. Let's do it this way. Then we apply for an asynchronous task like this. As y of a task. Then the first parameter, we specify it, Elm Street. Then we call it Bell Street. Then, here we can pass a lambda What we need to do with this lambda is we need to capture this progress. Mainly, if people try to capture it directly, it probably won't work. You can see there's no way to capture it here. Adding an equal sign, would that work? Taking the address doesn't seem appropriate either. Then let's ignore it here. We can just let it capture this. Because here we must emphasize this pointer. We must emphasize this pointer. When you write it this way, you must pay attention to its life cycle. I think it's fine to write this here. Because this subsystem exists along with the life cycle of our game instance subsystem, so it's fine. Then we can do something like this here. Let's take a look. We have a platform class, right? Let it sleep for 0.1 seconds. Okay. No need to add seconds. Let it sleep for 20 seconds. Then after 2 seconds, we finish executing. Then we execute this block of operations on the main thread. We can put this here. Then we write another one here. Then here we'll use game street. Then removing this here should work. We also need to replenish this focus review. Take a look here. The replenishment here should be placed here. That is, if using a ZS pointer in this place, you must be extremely careful. Yes, and then there is no need to sleep here. Because this is the main thread layer. Then the main thread layer executed. So here we are initializing. For this local action, we paste all of this. We paste all of them. Similarly, we should replace this light info here. Let's replace it with this form. Then we also replace the UE5 info. This loady for UI, we haven't actually used it yet. We don't need to worry about it. It's fine to just leave it as is. Okay, good. This way, we should actually need about 0.6 seconds to execute. Then let's first take a look at the result of this execution. So right here, we can actually simulate doing some work. And how do we actually do it? Let's do it like this. Let's write something. FPS. We grab an FPS. We get the save directory. We get the pred_save directory. What is this directory? It's actually this directory. After packaging, it's actually all before packaging is complete. Still, in this directory, you can see some crane shots here, right? And some asset checks. Let's take this directory. After taking this directory, we'll concatenate a string path. Let's call it shell gang control flow. Then you der info .txt. We haven't explained saving to everyone yet. This is quite awkward, but it's okay. It's okay. This doesn't affect anything. Because this needs to be added later. We call it utafrionen paths. Of course, in this path, you can hard code it. So you don't have to every time. You can put it up here. Putting it up here is fine too. The way we are doing it is because I need to test. So we'll just write it like this. Then we also need to convert this to an absolute path. Open it up a bit. Convert the relative path to an absolute path. So we have such a path now. Good. After having such a path, let's write something. For example, we'll use f_file. Helper this thing. Helper. Also say I'll file. Here we have a let's store a string to keep it simple. This will later store a string into this file. Then first is the string he wants to store. Then we can give one. User init. Async. ID. We just set it equal to this ID. This ID definitely has a value now. Then we let it output the actual value. Okay, then I think this seems a bit sparse. Let's store a time as well. Let's do it like this. Builder init data time. We just use f data time. then we take this time, then we should be able to let it to actual. But I'm not sure about this actual distance, whether it's what we want. Let's find one. Find an actual distance that can be seen, a more convenient actual distance. This is to get a certain part. We need to get one. We saw it earlier. Let's just use this one. Our HTTP state. Okay. So now we have an actual distance. Then here we need to use the actual distance. Write it this way. Because this is actual. Save. Save array. This save array, you can see it pass a tent. Here we pass save, so we should write it like this. It's better. Here we give it a tel vevs. Oh, actually, here you can use some of our little tricks. For example, how to add an array. We also covered that in the array chapter. Growing right, but we didn't write it that way here. For example, something like implants and things like that. Okay, good. Let's write this part in here. Then this path here, the first thing we pass is, it should be. Let's convert this path of ours into here. Actually, the main thing we need to emphasize is this. This is actually quite important. We need to force UTF-8 for this. We can use the last one. Yes, obviously here. It must include the file helper header file. Include it. Actually, let me check this file helper. Let's finish including it first. I'll continue explaining to you afterwards. He has arrived safely. Let's take a look at where this path is. It is inside the mesh. Actually, we will explain it to you later. For something like this, this thing must include the say key when pasted. And actually, you also need to include this asset task. Okay, let's check the reason for the error here. You also have a struct here. Async. This should be fine now. This way. Let's see if there are any errors on the edge. No problem. Because there is an NC here. Because this is how it works. If you don't write it this way, sometimes there will be this issue. You can see this place. That is, if you turn it into this thing, then the problem is huge. You cannot turn it into this thing. Cannot turn it into NSON. And this thing, actually, we also need to include it. Why does it need to be included? Look at its path. Here, seek or if you don't include it, when you package your project, when packaging the project, it generally won't package incorrectly. But when you package the plugin, it will package incorrectly because it doesn't have that n-level context. So it will report an error. Things like basics 4 or fail helper pays and such actually all need to be included. So since we've mentioned it, let's guide everyone to include it. Actually, this path, if you have a good memory, memorizing it should also work because it's actually, this path is very easy to understand. It's all under this mess or sum. It's a very standardized way of writing. You can understand. This should be called fpass. Obviously, it's reporting an error here. It should be like this. This doesn't work either. This is a bit of a headache. Wait a moment. Let me check this path again. Where exactly is it? It's PACH under MIC key. My space. Okay, good. That should be fine now. Then go back here. Then here, during the initialization process, I'll break it down for you. It will write this information. So if you want to read this information, how do you read it? It's actually very simple. Here there is a fail helper like this. I'll write it here for everyone because we didn't cover this class separately. It's a bit of a pity because it's relatively simple. Because the main time is loop frame to stream array. This way it will read it as a stream array. Then when you read it here, you just pass this in, okay? Let's take a look at this parameter. We can check it like this first. Okay, like this, you see. We can tell by looking at the comments. This part is converting a txt text into lines. This part is writing it in. Right. It's writing these in. It's very easy to understand. Then, as for the specifics, everyone, I would just comment this out like this. Okay, let's test this for everyone. Now, check if our own step process has taken effect. Okay, let's initialize here. Let's initialize. Hey, take a look at 21.7.231. 20t then 0.1. None. 2. Let's look again. Look again. This is quite fast because it just flashes by later. Since we only have a little time in total, we didn't write anything later. It flashes by. This is perfectly fine. Then let's check again. Our sales, hey, as soon as you see it, hey, what is this? This is our streamlined. This is the ID and time. Actually, this is just a relatively simple, commonly used method. Then you might ask, what if it fails? So let's write a failure case here. For example, let's force it to fail. Here, if it succeeds. You see, if it succeeds. If we still treat it as a success here, then we'll let it go this way. If it fails, we'll make it go here from here. So we often have a way we can define a red. So there's no need to modify the code. We call it defend. Let's define it. The way it initializes successfully or fails. This also has a take. Then we define it as failure. Okay. After defining it, we use it here. Use it directly here. So this place obviously fails. Actually, we don't really need to update this progress. Here, we directly give this. This place might have failed initialization. Then here we give a force. This is called test failure. Test failure. Okay, there is actually a point worth noting here, which is, what is it? It's about this cancel flow. Whether you should write it above or below, because if you put it here in the blueprint to do, he might fail when going out later. Then it lets you click again for the next success, then the next initialization. Then you come back to this place again. That wouldn't be quite right. So I think this should be placed above. Actually, sometimes above. Whether it's above or below needs to be decided based on the project situation. Then later, you will actually see a way of writing it. One way is through an Async Gamer 3. Execute this broadcast 1 frame up or down. Actually, whether you put it above or below doesn't matter. So these two positions, above and below, need to be chosen based on the actual situation, because you execute the blueprint first. After the blueprint finishes executing, then go back to this place and execute cancel. Then we directly cancel here. Then let it execute this on its own. Then if we cancel here, then after execution, we reset this place to 0 again. Actually, here we need to write a method specifically for releasing resources. Otherwise, your code will fail here. Will also fail here. Will fail here. You write very redundant code. Okay, we are only testing its failure here. So we are here. Let's just write it like this for now. Okay, good. This part of ours will obviously fail. Right, look, it failed. The test failed. Because isn't it interesting? Look, if we click continuously, it will actually prompt that it is in the process of rough shaping. You can see, isn't it interesting? Such a rough shaping process. Okay, so this lesson is basically over here. Okay, I think we've covered the country flow pretty well. Yes. So, if there's still some time, I usually write it like this. I usually write it this way. This course prototyping failed thing. I'll write it like this. I'll do it this way. We still need a games tree here. I'll just come over. I usually like to do it this way. Even though I'm already on the main thread, I'll have it jump back to the main thread to do this. And the data here, we all need to make a copy of it. No need to copy this. This progress is not needed either. We only need to copy this subset. So actually doing it this way, it doesn't matter whether it's above or below, because it will be executed in the next frame anyway. Actually, after this frame, it won't care about the rest. This thing will be copied to execute in the next frame. Because you really don't know the blueprint, folks, we'll remove something. It's very possible that right here, they will execute it again immediately. Then it will obviously be wrong, because it will trigger this thing. That is, it will trigger here. It will trigger the thing here. This will trigger it. And sometimes if you haven't written this part here, then it will trigger an assertion here. That is, you added a new element to the host inside a loop. Remember what I said. If you need to add to the host inside a loop, it's the engine's HTTP. Weibo said they all have this issue. So you must execute it with a breakpoint. You must execute it with a breakpoint. Okay, then we'll stop here for this lesson. That's about it for the country flow. And here we are just simulating reading this data for everyone. Right here, right? Write this data. We haven't read this data yet. We can move this read operation earlier. That should be fine. For example, read it before logging in, then process the input data. If successful, we update the local data. If failed, we let the initialization process fail. Okay. We'll stop here for now.